Starting today, we will take a deeper look at the two transport layer protocols, UDP and TCP, that are built upon the best effort IP service. We will focus more on the TCP. UDP is unreliable and connectionless. It is a very simple protocol that provides only two additional services beyond IP, demultiplexing and error checking on data. IP knows how to deliver packets to a host. UDP adds a mechanism that distinguishes among multiple applications at the host. Connectionless means there is no handshaking and no state information. Therefore, the protocol is of low overhead. By UDP, datagrams can be lost or out of control. There is no flow control, no error control, and no congestion control. The format of the UDP datagram is shown in the figure. The destination port allows the UDP module to demultiplex datagrams to the correct application in the host. The source port identifies the particular application in the source host to receive replies. Port numbering has certain rules. For example, from 0 to 255 are reserved for well-known ports. This diagram illustrates the demultiplexing process. All UDP datagrams arriving to IP address B and destination port number N are delivered to the same process. Source port number is not used in demultiplexing. The UDP checksum field detects end-to-end errors in datagram. It covers so-called pseudo-header followed by the UDP datagram. The pseudo-header includes the IP addresses in order to detect misdelivery. UDP receiver recalculates the checksum and silently discards the datagram if errors detected. By silently, it means no error message is generated. The use of UDP checksums is optional, but hosts are required to have checksum enabled. The Transmission Control Protocol TCP provides a connection-oriented, reliable, in-sequence, byte-stream service. It enables error control, flow control, and congestion control mechanisms. It has high overhead, but most applications use TCP because of the reliability. A TCP connection is uniquely identified by 4 parameters: the sender IP address and port number, and the destination IP address and port number. An end system can then support multiple simultaneously TCP connections. TCP doesn't preserve message boundaries and treats the data it receives from the application layer as a byte stream. It groups bytes into segments and transmits segments as convenient for efficiency. For example, the application writes 45 bytes, 15 bytes, and 20 bytes to the TCP socket. The transport layer may split, combine the information, and pack it into segments in the way it finds most appropriate for transmitting over the underlying networks. In this example, it may send 2 segments, each 40 bytes, to the connection. Error detection and retransmissions are enforced in TCP. Please refer to an earlier lesson on TCP reliable stream service for more information. TCP flow control function is implemented through an advertised window field in the TCP segment header. Segments that travel in the reverse direction contains advertised window size that informs the transmitter the number of bytes that can be currently accommodated in the receiver buffer. This figure shows the format of the TCP segment. The header consists of a fixed port plus a variable size optional field. By padding, the length of header must be in multiples of 32-bit words. The minimal header length is 20, and the maximum header length is 60 bytes. Header length specifies the length of the TCP header in 32-bit words. This information allows the receiver to know the beginning of the data area because the options field is of variable length. The 16-bit window size field specifies the number of bytes the sender is willing to accept. This field can be used to control the flow of data and congestion. Sender will accept the bytes with sequence number from ACK to ACK plus window. The TCP checksum calculation procedure is similar to that used to compute an IP checksum. It calculates the checksum for the TCP pseudo-header and data segment. This ensures the receiver that the segment has reached the correct destination host and port, and the protocol type is correct. Note that the pseudo-header created by source and destination hosts during the checksum state is not actually transmitted. The TCP pseudo-header has similar format as that of UDP. This concludes today's lesson.